Welcome back viewers to my channel. In this video we will solve some of the numerical problems from current electricity. The first question that we will solve is calculate the equivalent resistance between the points C and B as shown in figure. So as we can see from here, it is given this is a point A and this is a point B. So to calculate the resistance between the points A and B as shown in this figure, first we will break this circuit. So here I'll mark to be a point C. Here I'll mark by D. Here I'll mark by E, and at this point I'll mark by F. So first of all, we will calculate the equivalent resistance between the points C and F. So let me put this one is C, this one is D, this one is E, this one is F. So as we can see from here, the resistance between C and D is this. The resistance between D and E is this. The resistance between E and F is this one. So here it is 5 ohm, here is 5 ohm, and here also 5 ohm. Now between C and E, so we are joined by this line. So therefore I will draw like this, and similarly the point D and F, it is joined by this line. So here I'll draw like this. Now as we can see from here, in between C and E there is no resistance. So this implies that point C and E are coincide. So this is C and this is E. And similarly in between point D and F, it is joined by this. So there is no resistance between D and F. So this implies that D and F are coincide. So in between C and D, it is 5 ohm. So let me put like this. Then in between D and E, again it is 5 ohm. And also in between E and F, it is 5 ohm. So as we can see from this figure, this 5 ohm, this 5 ohm and this 5 ohm, they are in parallel. So therefore the equivalent resistance we can write like this, 1 by Rp. So this one is equal to 1 by 5 plus 1 by 5 plus 1 by 5 ohm. So here 1 by Rp, it is equal to 3 by 5. And from here, we can write Rp. It is equal 5 by 3 ohm. So this 5 by 3 ohm is a resistance between the point C and D. So now, let us redraw this circuit. This is A, this is C, and as we can see from here, there is no resistance between F and B. So therefore, this implies that F and B are coincide. So I can put B instead of F. So in between A and C, this is 5 ohm. And in between C and B, this is 5 by 3 ohm. As we can see from here, this 5 ohm and 5 by 3 ohm, they are in series. So therefore, RS is equal to 5 ohm plus 5 by 3 ohm. So this is equal to, so 3 multiply 5 is 15. Then 15 plus 5 is 20. So we'll divide by 3 ohm. Since the series connection of this 5 ohm and this 5 by 3 ohm is the resistance between 2 point A and B. So therefore, instead of RS, I can also write RAB is equal to 20 by 3 ohm. So this is the equivalent resistance between the points A and B. The second question that we will solve is this question. If R is equal 20 ohm, calculate the total current through the circuit shown in figure below. So first of all, let us mark this point to be A and this point to be B. So first, I will break this circuit. So this is A and this is B. And I will mark this point to be C, this point to be D. So here it is C, here it is D. So in between A and C, the resistance is R. In between C and D, there is no resistance. In between A and D, the resistance is R. In between A and B, the resistance is R by 2. And in between B and D, the resistance, it is also R by 2. So as we can see from here, there is no resistance between C and D. So this implies that point C and D are coincide. So if we redraw this circuit, we can draw like this. This is A, then this is D, then this is B. So from here to here, it is R by 2. From B to D, it is also R by 2. And now, from A to D, it is R. And from A to D, it is also R. because C and D are coincide. So this R and this R, that's mean this resistance and this resistance, they are in parallel. So the equivalent resistance between these two, I can write 1 by Rp equal 1 by R plus 1 by R. So from here, I can write 1 by Rp. So this one is equal. So 1 by R plus 1 by R, it is nothing but 2 by R. Rp equal R by 2. So now if you redraw this circuit, so I will mark this one as A, this one as B. From here to here, it is R by 2. And then from A to D, again it is R by 2. And from B to D, it is also R by 2. So now, the resistance between A and D is R by 2. And the resistance between B and D, it is also R by 2. And these two resistance, as we can see from here, they are in series. So if you redraw this circuit, this is A, this is D, and this is B. Also, another resistance from A to B, this is R by 2, like this. So R by 2 between A and D. Then between D and B, it is also R by 2. As we can see from here, this resistance R by 2 and this R by 2, they are in series. So the equivalent resistance can be written as Rs equal R by 2 plus R by 2. So R by 2 plus R by 2, we can simply write here as R. So again, we can redraw this circuit. This one is A, this point is B. So from A to B, we can write here R. And again from A to B, if we take with this one, it is R by 2. And this resistance R and this R by 2, they are in parallel. So therefore, 1 by Rp is equal to 1 by R plus 1, then R by 2. So this 2 will go up like this. So we can write 1 by Rp is equal 1 by R plus 2 by R. So 1 by Rp equal R. So we put here 3. Then Rp is equal R by 3 ohm. So this is the equivalent resistance between the 2 points A and B. So now, finally, we will calculate the current flow through the circuit. So let me redraw the circuit. So this is a point A, this is a point B. The resistance between A and B, it is R by 3. And from A, we connect to a positive terminal. And from B, we connect to the negative terminal. And the voltage from the source here, it is 10 volt. Now we will calculate the current through the circuit. So here, if you use this diagram, we can write V is equal IR. But here the resistance across A and B is nothing but R by 3. So this implies that 3V equal I multiply R, or I equal 3V divided by R. Also, by given condition, V is 10 volt, so 3 multiply 10, and R, it is also 20 ohm, so therefore 0 will get cancelled. So 3 divided by 2 is nothing but 1.5 ampere. So this is the current flowing through the circuit.